right, so in the last... All right, welcome back. Okay, so in the last video, we were just talking about the kind of the two big things that we want to look for in regression, right? Before we even really do anything. And the first thing is making sure that our data are related linearly, right? So, because we already know that our data existed before we went out and drew this line, right? Okay, so we just want to make sure that when we draw this line, that we're actually, defining the relationship between these two things appropriately, right? And then we want to make sure that our residuals, the amount of error that we're making, the amount of mistakes, essentially, we want to make sure that those are normally distributed, okay? And it turns out that, this is one thing, let's go to this one, because this is a good example here. This residual, right, if we were to draw a line from this data point all the way down here, this value, this residual is a huge, huge residual, right? So what's happening here is that if we were to say, okay, the relationship between x and y, in this case, it's only x and y, very basic. The relationship between x and y is whatever the formula is for this, right? Okay, then somebody comes up to you and says, okay, well, if I were to plug in 3 here into my x value, into my x spot here, right? So we'll just recall, right? We'll just plug in an x value. If I plugged in whatever this is, 3.1, well, what my line is going to tell me is that the data point would be this on the y-axis, like right there at about 5 or so. But in real life, that data point showed up way up here, okay? So I'm going to be big time underestimating, right? I'm going to be big time underestimating. And the same thing over here too. We have this whole thing here is kind of like curving downward. Whoops, it's kind of curving downward like that, and then upward, it's kind of scooping like that. With this data point, if we zoom way in or way down, well then, if I were to plug in whatever this is, right, 0.7 or so, well, I would trace up and then over, right, to whatever this y value is. Well, I'm going to be overestimating just a little bit for this 1, right? Because in reality, the actual value is there, but what I would be predicting is a little bit higher, right? So I'd be overestimating, okay? So that's kind of the big deal, is that if we were to then just plot all of the distances between our points in the line here, right? We get some small ones, some big ones, and then plot them on a histogram, well, that's going to be some funky distribution. I think that it would be a little bit left, right? And it would be a little bit left skewed, okay? So we want that normal distribution. We want that normal distribution of residuals so we can rest assured that we're not going to be doing a whole ton of over and underestimating like all the time, right? It's okay to be wrong a bit, right? It's okay to be wrong a bit, but you don't want to be like, in this case, you're big time wrong all the time, right? Whereas this one, right, this one here, we know that if I were to plug in x into here, it would predict this value, right? Even though the data points kind of around it are a little bit further away, there's no big deal, right? It's not that big of an over or underestimate, right? Because our line would be doing that for every single point here. Whereas in this one, we're going to be big time underestimating all the time, but then over here we're going to be big time overestimating, and then kind of the same on this side of the line too, right? So we're just being very inconsistent with how we define the relationship here, right? Since our data kind of has this curved nature to it. Okay, blah 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 blah, right? That's a big recap of the last video. Here's a little bit about the checklist, right? The first thing you want to do is plot x and y, right? Plot your two variables. And then construct the linear model, right? That's given to you as y equals beta naught plus beta 1 x, right? We've got that. And then we just want to make sure that everything is in a straight line, that our line that we did draw is actually doing a good job of defining sort of the relationship there. Make sure that our over and under estimations are consistent. So that's all good. And then you just report your results, right? And I will tell you during the test, which is this Thursday, and on the exam and everything, I'll ask for specific things. Okay, so in real life, you would more likely than not report this, and maybe something else. Sometimes you report that interpretive sentence, that for every 1 unit increase thing. Sometimes you do that, but not all the time in real life. Okay, let's talk about a little bit of misuse. How can we kind of finagle the results here, or finagle the process? So we have this idea of extrapolating, right? So what we're trying to do here, is we've got some data. I draw this all the time. Some data, and we draw a line through it. Okay. What we can do is we can make some inference about what's going on. So if I want to say, if I were to plug in this x value, I would get this y value, right? That's what's happening here. Okay. And that's fine. That's totally legitimate, right? We're able to say, okay, the slope of this line just tells me how x affects y. Easy peasy. And then I can use this for prediction too. If I were to plug in this x value, what y value would it be? And that's all legitimate, right? That's all fine. But if I were to come over here and say, okay, what if I were to plug in this value out here, right? This x value. Well, what you could do is draw this thing way out here, okay? But here's the deal. Is that we have no idea what the data look like out there. We only have data for this range, okay? So doing this is called extrapolating, okay? We're trying to use the information that we found here, and we're trying to apply it to way out here. But we just cannot do that because we just don't know. We don't know. Is it likely that the data kind of still do this thing? Maybe, right? But we just don't know. We do not know, okay? There's a few other things that we can do in regression, allowing outliers to overly influence the results, combining groups inappropriately, using correlation to describe curvilinear data. That's what I was talking about over here, right? Over here. This is considered curvilinear because it's curved. Pretty cool. English is crazy. But that is curvilinear data, but we're using this line to define it. That's no good. That is against the rules because we're using this to tell a story that's not actually happening. Okay. The two kind of things in here we're not going to so much worry about in this class, but just kind of keeping that in the back of your mind for when you go into the next stat class, hopefully, and then you've kind of got that in your arsenal of how you can misuse this, right? But the big deal here is extrapolating and then using a straight line to describe something that is not linear. Okay. A little bit more on extrapolation can be seen here. I'll let you read that on your own, but the general idea again is just trying to use your regression equation to predict something that you just do not have information for. So that goes in both directions. So over here and over this way too. No good. Cannot do that. Okay. I'm gonna pause the video actually one more time just to give you a break, and then we'll get back into it. So I'll see you here in just a sec.